In this video, we're going to look at another example of integrating a quadratic expression. So the idea here is to complete the square first so that we can apply trig substitution. Inside the radical, we have minus x squared minus 12x plus 64. Let's factor out negative 1 from the first two terms, x squared plus 12x. And let's write plus 64 outside the brackets. Now the idea is take the number 12 and divide by 2 and square it. That gives us 12 over 2 is 6, 6 squared is 36. So that's the key. Add and subtract the same number. Add 36, subtract 36. So what we have is minus 1 times x squared plus 12x plus 36. And we have negative 1 times minus 36, that is plus 36, plus 64, that gives us plus 100. But now this part is a perfect square. So what we have is minus 1 times x plus 6 squared plus 100. Let's rewrite that as 10 squared. 10 squared is 100 minus x plus 6 squared. Alright, when we have the pattern, root of a squared, constant squared minus variable squared, we make the transformation u is equal to a sine theta. Differentiate both sides, we get du is equal to the derivative of sine is cosine. So du is a cos theta d theta. We have root of 10 squared minus x plus 6 all squared. So x plus 6 is equal to 10 sine theta. Differentiate both sides, we get dx is equal to 10 cos theta d theta. Alright, so what we have shown by completing the square is the integral of 1 over root of minus x squared minus 12x plus 64 dx is equal to integral of 1 over root 10 squared minus x plus 6 squared dx. This is very important to be able to complete the square so that you can start the question, so that you can apply trig substitution. Otherwise, we couldn't even start the trig substitution. So we have constant squared minus variable squared, x plus 6, that's our variable, is equal to 10 sine theta. That's the trig substitution we'll be applying, a sine substitution. dx, differentiate both sides, dx is equal to 10 cos theta d theta. So we have root of 10 squared minus x plus 6 squared. This is equal to root of 100 minus x plus 6, that's 10 sine theta, all squared. If we do a bit of algebra and remove the 100 outside the radical, root of 100 is 10, factor it out, we get 10 root of 1 minus sine squared theta. But this is a trig identity. Cos squared theta plus sine squared theta is equal to 1. So 1 minus sine squared theta is equal to cos squared theta. So we get 10 root of cos squared theta. And what we get is 10 absolute value of cos theta. Root of cos squared theta is absolute value. But because of the way we restrict the angle theta, we're able to drop the absolute value. So we get 10 cos theta. So this is very important. We had a very complex expression, root of 100 minus x plus 6 squared, this expression, and by applying the trig substitution, we're able to remove the radical and come up with something much simpler. So the integration now will be possible. So we have integral 1 over root of 10 squared minus x plus 6 squared dx is equal to 1 over 10 cos theta times dx, which is 10 cos theta d theta. Let's label everything. This part here, this is dx. This part is going to be 1 divided by root of 100 minus x plus 6 squared. So you can see we've essentially turned it into a trig integral that's now very easy to solve. 10 cancels with 10, cos theta cancels with cos theta. What we're left with is integral 1 d theta. Antiderivative of 1 is just theta plus c. All right, so we can't stop there. We have to actually get our answer in terms of x. So what we have is our trig substitution is x plus 6 is equal to 10 sine theta. Solving for sine theta, we get sine theta is equal to divide by 10 both sides. Sine theta is x plus 6 divided by 10. Now let's create our triangle, the reference triangle. So here we have right angle triangle. Here we have the angle theta. Sine theta is x plus 6. That's opposite. Over hypotenuse, that's 10. So sine is opposite. That's how we create this triangle. Always start with the, if you have sine, it's opposite over hypotenuse. If you have cosine, it's adjacent over hypotenuse. If it's tangent, it's opposite over adjacent. So just label the opposite side as x plus 6. The hypotenuse is 10. Then now we apply Pythagoras to solve for the missing side. So we get 100 minus x plus 6 squared. All right, so we have theta is equal to, now take inverse sine of both sides. We get theta is equal to sine minus 1 of x plus 6 over 10. So we can now get the answer in terms of x. The integral is going to be equal to theta plus c, but theta, we have got that in terms of x. So that's going to be sine minus 1 of x plus 6 divided by 10 plus c. All right, thanks.